Hi guys, Alex here. 2008 exam paper, June Physics. I'll be going through electronics. Just before we go on, I'll mention that 2008 is before the current curriculum design, but most of it's the same. So I've been looking through and reading all the different reports and what's actually different. And I think the main difference is between this and 2009 is in this one they have capacitors, 2009 they don't. That's one of the differences in electronics. So we'll just skip all the questions that aren't relevant. Okay, are you ready? Reading time begins now. Sorry about the brightness. Go. So, it's a light emitting diode. It's a pretty regular kind of graph. We know it takes up a certain amount of voltage. And now we're looking at this diagram and it's asking what the current for the LED is. So even without knowing anything, I look at this graph and I'm like, 2.5 volts is something special. There's nothing else special about this graph. 2.5 volts. So I know this LED takes up 2.5 volts. Therefore, if this is 8 minus 2.5 means this is going to take up 5.5 volts. Now we use current equals voltage on resistance, 5.5 over 300. Easy peasy. Okay, next question. So it's a complicated circuit. And I think some of you won't understand what these are. That's okay. Maybe we don't need them. With no input signal, the DC voltage is measured between point P and Earth. What will be the value of this DC voltage? So we want to know the voltage between P and Earth. What we do know is this is 6 volts and this is 0 volts. So regardless of all these things, we can just look at this circuit. It has to go from 6 to 0 across this circuit. So, voltage divider formula. We know here, R on R total times V in equals V out. So R, we're looking at this one, 1 kilo ohm, divided by total, which is 3 kilo ohms, 1/3 times voltage in 6 volts. 1/3 of 6 volts is 2 volts. 2 volts will go out. Still with no input signal, the current through RC is measured to be 3 milliamps. What will the voltage between point Q and Earth be? So this is a hint. This is saying we want to know from Q to Earth, but they tell us there's 3 milliamps going across here. So we can figure out how much voltage drop goes across here. 3 milliamps times 1 kilo ohm, or 1000 times 3 divided by 1000, or 3 times 10 to the negative 3, gives 3 volts. Goes 6, we subtract 3, we get 3 volts. It's 3 volts to Earth. 3 volts. What is the power dissipated in resistor RC? Well, RC. Well, we know the current and we know the resistance, so we just use power equals I squared R, current squared times resistance. I'm doing this on separate sheets of paper because I kind of used the other for a different video. The graph of V out versus V in for the transistor amplifier. Amplifiers. What is the voltage amplification of the amplifier? Well, what do we know about amplifiers? We know their gain is the gradient, is V out over V in. V out over V in. The inversion means, or inverted, means it has a negative gradient. If we put a positive voltage in, out comes a negative. That's why it's inverted. Operating point is the center of the linear region, and clipping goes when you go beyond these lines. Okay? When you go to the horizontal part, because you can't get any higher voltage free. So, voltage amplification, that sounds like the gain. It's how much that gets amplified. So it's 3 volts up divided by 60 volts across, 60 millivolts. So it's 3000 millivolts divided by 60 millivolts, gives you about 50 gain. There's no units for gain. Explain the shape of the graph in terms of the negative slope, while it's horizontal sections at greater than 60 millivolts and less than minus 60 millivolts. Negative slope just means it's inverted. This is an inverting amplifier. Horizontal sections means that at this stage it gets clipped that the input voltage is going beyond the range of the allowable inputs, which is minus 60 millivolts to 60 millivolts, or a range of 120 millivolts. And yeah, so this is where it's going to get clipped and distorted. Okay. So that would be our answer. The key points are inverted, clipping distortion, range is 120 millivolts. Here's an input signal. On the graph below, sketch the output signal at point B out. What the question is asking is, we have this signal, we're going to put it through here, and we're going to get a signal out here. So what do we need to know what the signal will look like? First is it inverting or not? Yes, it's inverting. So this will go upside down. Next, is it distorted? Is there clipping distortion? Well, we have 100 millivolts coming in. It doesn't go up to 100 millivolts. The linear only goes up to 60 millivolts. So it gets clipped at 60 millivolts. So it's going to get clipped here. Well, we're going down now, but if we were just clipping, it'd be here, 60 millivolts. Because it's inverted, it goes upside down, like that. That's what a graph will look like. The final thing we need to know is the scale. Okay, we have the shape, we need the scale. So what's the maximum voltage out? 3 volts out. So when we get clipped here, that'll be 3 volts. So, inverted, it's going down, it's getting clipped, maximum is 3 volts. It's inverted, going down, it gets clipped, maximum is 3 volts. How many times? It goes back to 0 there. So, it goes like this. Yeah, and that's exactly upside down, it's clipped, and 3 volts. Easy. Okay, this is a capacitor question. It's not in the paper. What value is the resistor of the thermistor, resistance of the thermistor at 20 degrees? You can read all that later. It's good to read the question, but I'm just trying to get you the main core of the idea. 20 degrees, 1,000 ohms. 1,000 ohms. Thermistor is incorporated into the circuit. I'm going to try and lock this so you don't get those white flashes. Okay. So the circuit below for cool room, just have a read of it. Okay, in summary, we have a thermistor which has different resistances depending on the temperature. Who cares? We'll just call it a resistor for now. We have another resistor which we decide the value upon. If this voltage across here is greater than 4 volts, the unit switches on. If it's less than 4 volts, it switches off. We want the refrigeration unit to turn on when the temperature rises to or exceeds 5 degrees. Okay, so what value of R should we set? It sounds like a complicated question, but all we really need to do is convert our information to things we can use. This is 5 degrees. Our resistor, 5 degrees, is 4,000 ohms. This is 4,000 ohms. We know this needs to be 4 volts. So if we subtract that, there must be 8 volts happening up here. 4 volts, 8 volts, 4,000 ohms. We want to find out what this resistance is. Now here's the thing. The voltage drop is proportional to the resistance, or V equals IR. So if this is dropping 8 volts, and this is 4,000 ohms, and this is dropping 2 volts, like, alright, this is dropping 4 volts, this is dropping 8 volts, they must be in the same proportion. So if this is 4 to 8, this must be half of that. 4 to 8, half of that. Yeah, easy. Voltage divider formula if you want to use it. So this resistance will be half of that, which is 4,000, this will be 2,000 ohms. Cool room is not cold enough, 2,000 ohms. To set the temperature lower, should R be increased or decreased? Explain your answer. To set the temperature lower, if we say, okay, if the temperature is going lower, first of all, we need to understand what's happening. Like, we need to use this. If the temperature is going lower, we're going to have a higher resistance at the top. This resistance is going to be higher. So if this is higher and we still want the same proportion of 4 to 2, I mean 8 to 4, if this goes higher, this also has to go higher. Same ratio, same ratio. Okay, so the answer is R should be increased. And that's it. That's all electronics. Okay, have a good time, guys. Don't study too hard. Enjoy.